Now today we are going to continue with exercise 1.1, question number 6. Now question number 6 says that R is a relation which is defined on the set A, which is equal to 1, 2, 3, and the relation R is given by 1, 2, 2, 1. So relation R has been given to us in the question in the roster form. We need to prove that this is symmetric, but this is neither reflexive nor transitive. So for reflexive, we need to check that A belongs to R for all A that the elements of A. So we can clearly see that 1, 1, 2, 2, 3, 3, they are not present in R. So we can give an example to show that this is not reflexive. So we are going to write, since 1, 1 does not belong to R, therefore R is not reflexive. Now we'll move to the symmetric part. In order to check the relation, whether that relation is symmetric or not, we need to see whether if A, B belongs to R, then B, A also belongs to R or not. So clearly we can see that 1, 2 belongs to R and 2, 1 also belong to R. So this relation is symmetric. And when the relation is symmetric, we need to prove it generally. So we will write, as we can see, A, B belongs to R implies B, A belongs to R. Therefore, the relation R is symmetric. Now we will move to the transitive part. For transitive part, we need to check whether all the combinations A, B, B, C, if they belong to R, then A, C belong to R or not. We can see 1, 2, 2, 1 belongs to R. So if we take this as AB, this is BC, then A, C is 1, 1, which is not present in R. So this relation is not transitive. So how we are going to write? We will write 1, 2, 2, 1 belongs to R, but 1, 1 does not belong to R. So this is A, B, B, C. A, B, B, C. They belong to R, but A, C, which is 1, 1, does not belong to R. Therefore, the relation R is not transitive. So the relation R is not transitive. Now we are going to move to the question number 7. Question number 7 here. R is the relation defined in the set A of all the books in the library of your college. So A denotes all the books in the library of your college. Relation R is defined as X, Y such that X and Y have same number of pages. X and Y have same number of pages. So we need to show that this is an equivalence relation. So first of all, we will check the reflexive. Reflexive के लिए we have to write, consider X, X. अब X, X is the same book. If X have 20 number of pages, then X has 20 number of pages. So X, X, it means the same book. So we will write, since X, X denotes same book, therefore they will have same number of pages. Therefore they will have same number of pages, and therefore we can say that R is reflexive. Now we'll move to symmetric. Now how do we prove symmetric? We will write, let X, Y belongs to R. Now, if X comma Y belong to R, this implies books X and Y will have same number of pages. If X comma Y belong to R, this implies X and Y will have same number of pages. अब जब X and Y have same number of pages, then Y and X also have same number of pages. This implies Y and X have same number of pages. Y and X have same number of pages. This implies Y comma X belongs to R, and therefore the relation R is symmetric. Let X comma Y belong to R. This implies X and Y will have same number of pages. तो अगर दो बुक्स के सेम नंबर ऑफ पेजेस हैं तो x comma y बोलो या y comma x बोलो. Y comma x, so y and x will also have the same number of pages. Therefore y comma x belongs to R, and therefore we can say that the relation R is symmetric. Now, if we talk about transitivity, we will write let x comma y, y comma z belongs to R. तो अगर x comma y एक ordered pair R को belong करता है, that simply denotes that x and y will have the same number of pages. This implies x and y will have same number of pages. This implies x and y will have same number of pages. X comma y belongs to R. This implies x and y will have same number of pages. Y comma z belong to R. This implies y and z will have same number of pages. Y and z will have same number of pages. So x and y have same number of pages. Y and z have same number of pages. So from 1 and 2, what we can conclude? From 1 and 2, we can conclude that x and z will have same number of pages. X and z will have same number of pages. Therefore, x comma z belongs to R, and therefore the relation R is transitive. And therefore the relation R is transitive. Now we'll move to next question, question number 8. Question number 8 says that the relation R is defined on the set A, which is equal to 1, 2, 3, 4, 5. And the relation R is given by A comma B such that modulus of A minus B is even. We need to prove that this is an equivalence relation. Now in this case, no need to write your R in roster form. Because if we are going to write the elements, we are going to get many elements. The questions such as A minus B is integer, A minus B is even, A minus B is a multiple of 4, A minus B is a multiple of 3. All these questions can be proved in a generic way. So we'll start with the reflexive part of this question. So for reflexive, we always write consider A comma A. Now what do we need to check? We need to check that A comma A belongs to R or not. So for that, if we write modulus of A minus A, that is 0, and 0 is always even. This implies modulus of A minus A is even, and this implies A comma A belongs to R for all A that belongs to A, and hence our given relation is reflexive. Next, we'll move to the symmetric part. For symmetric, we will write let A comma B belongs to R. Symmetric में we assume that let A comma B belongs to R, and we prove that B comma A also belong to R. So for the symmetric part, we will write let A comma B belongs to R. And this simply means modulus of A minus B is even. Now you know what is the meaning of the modulus. Modulus means if there is a negative number, make it positive. So like modulus of minus 2 is 2. Modulus of 2 is 2. So if modulus of something is even, it means that number is also even. So if A minus B is, the modulus of A minus B is even, so we can conclude that A minus B is also even. Now tell me, if 4 is even, minus 4 is also even. If 6 is even, minus 6 is also even. So if A minus B is even, so the negative of A minus B, which is B minus A, is also even. So modulus of A minus B is even implies A minus B is even, which implies B minus A is even. And if a number is even, then its modulus is also even. So this implies modulus of B minus A is even, and therefore we can conclude that B comma A also belongs to R, and hence our given relation is symmetric. Let A comma B belongs to R. This implies modulus of A minus B is even. If the modulus of a number is even, it means that number is also even. So A minus B is also even. If a number is even, then its negative is also even. So if A minus B is even, then B minus A is also even. And if a number is even, then its modulus is also even. So modulus of B minus A is also even. And hence we can say that B comma A belongs to R. Now we'll look at the transitive part. Now for transitivity, we will write let A comma B, B comma C belong to R. Now this simply means modulus of A minus B, modulus of B minus C is even. Both modulus of A minus B and modulus of B minus C are even. Now just now I explained you, if the modulus of a number is even, the number is also even. This implies A minus B, B minus C. Both these numbers are even. Now, if 2 is even and if 4 is even, their sum is 2 plus 4. That is 6. That is also even. As we know that the sum of even numbers is also even, so we can say A minus B plus B minus C is even. We'll cut minus B plus B. So this implies A minus C is even. If a number is even, then its modulus is also even. This implies modulus of A minus C is even. And therefore we can conclude that A comma C also belongs to R. And therefore the relation R is transitive. I'll explain it again. Let A comma B, B comma C belongs to R. This implies modulus of A minus B, modulus of B minus C is even. If the modulus of a number is even, the number is also even. So A minus B is even, B minus C is even. If we add both the numbers, since the sum of even numbers is even, so A minus B plus B minus C is even. So we can conclude that A minus C is even. And therefore modulus of A minus C is even. And so we can conclude that A comma C also belong to R. And hence our given relation is transitive. So we can say that the relation R is an equivalence relation. This implies that the relation R is an equivalence relation. The second part of this question is show that all the elements of 135 are related to each other. So suppose if I take this set 135, question is show that all the elements of 135 are related to each other. Means A comma B belongs to R. We need to show where A also belongs to this set and B also belongs to this set. This is the meaning of this question. Show that all the elements of 135 are related to each other. A is related to B. A is related to B. That simply means A comma B belongs to R. So if we need to show that all the elements of 1, 3, 5 are related to each other, that means if we need to show A comma B belongs to R, then A also comes from this set and B also comes from this set. What is the definition of relation? Definition of relation is modulus of A minus B is even. Then we will write A is odd, B is odd. The reason is very simple. Why? Because A comma B both belong to this set 1, 3, 5. A is odd, B is odd. Difference of odd numbers is always even. If we subtract two odd numbers, we are always going to get an even number. This implies modulus of A minus B is even. And therefore, we can conclude that all the elements of 1, 3, 5 are related to each other. The next part of this question says, show that all the elements of 2, 4 are related to each other. Show that all the elements of 2, 4 are related to each other. That means we need to prove A comma B that belongs to R. A also comes from this set and B also comes from this set. So how we are going to write? We will write A is even, B is even. The reason is very simple. Since A and B both belong to 1, 2. Then we will write difference between even numbers. Difference between even numbers is always even. This implies modulus of A minus B is even. And the concluding statement will be, therefore, all the elements of 2, 4 are related to each other. Therefore, all elements of 2, 4 are related to each other. And the last part of this question is that show that no element of 1, 3, 5 is related to an element of 2, 4. No element of 1, 3, 5 is related to element of 2, 4. Means if we take A comma B belongs to R, A belong to this set, B belong to this set. So we will write, since A belongs to this set 1, 3, 5, B belong to this set 2, 4. So this implies A is odd and B is even. All the values that A will take is odd. All the values that B will take is even. So A minus B क्या होगा? A minus B होगा odd minus even, which is always going to give you an odd number. This implies A comma B does not belong to R, and therefore we can conclude that all elements of 1, 3, 5 are not related to, they are not related to 2, 4. Hence, proved. Now, question number 9 is very similar to question number 8. A part of question number 9 is very similar to question number 8. The set A is defined as X such that X is an integer. X lies between 0 to 12. R is defined as A comma B such that modulus of A minus B is a multiple of 4. We have to apply the same pattern as we did for the last question. Modulus of A minus B is a multiple of 4. So for the reflexive part, For the reflexive part, we will write consider a comma a. Now modulus of a minus a is 0. 0 is a multiple of 4. 0 is a multiple of 4. Therefore, a comma a belongs to R for all a that belongs to a. Now for symmetric part, we are going to write let a comma b belongs to R. What does this implies? This implies modulus of a minus b is a multiple of 4. मॉड्यूलस ऑफ a माइनस बी इज अ मल्टीपल ऑफ 4. अगर एक नंबर का मॉड्यूलस 4 का मल्टीपल है, मॉड्यूलस क्या होता है, आई रिपीट, जैसे मॉड्यूलस ऑफ -2 होता है 2, तो अगर एक नंबर का मॉड्यूलस मल्टीपल ऑफ 4 है तो वो नंबर भी मल्टीपल ऑफ 4 है. दिस इंप्लाइज a माइनस बी इज अ मल्टीपल ऑफ 4. और अगर एक नंबर मल्टीपल ऑफ 4 है, जैसे 16 इज अ मल्टीपल ऑफ 4, तो उसका नेगेटिव क्या है, -16. -16 is also a multiple of 4. So if a minus b is a multiple of 4, this implies b minus a is also a multiple of 4. अब b minus a अगर एक multiple of 4 है तो उसका मॉड्यूलस b multiple of 4 है. So modulus of b minus a is a multiple of 4. So we can say that b comma a also belong to R, and therefore the relation is symmetric. Since modulus of b minus a is a multiple of 4, this implies b comma a belongs to R, and therefore the relation is symmetric. Now we look at the transitive part of this relation. For transitive, we are going to write let a comma b, b comma c belong to R. This implies modulus of a minus b, modulus of b minus c. Both are multiple of 4. अब जस्ट नाउ आई टोल्ड यू, अगर मॉड्यूलस मल्टीपल ऑफ 4 होते हैं तो उनके नंबर्स, जो मॉड्यूलस के अंदर जो नंबर्स हैं वो भी मल्टीपल ऑफ 4 होंगे. दिस इंप्लाइज a माइनस बी, b माइनस सी आर मल्टीपल ऑफ 4. और अगर जैसे सपोज 4 इज अ मल्टीपल ऑफ 4, 16 इज अ मल्टीपल ऑफ 4, मैं दोनों को ऐड करूंगी, आई एम गोइंग टू गेट 20. 20 is a multiple of 4. So if I add both the numbers a minus b and b minus c, so this will also be a multiple of 4. This is a multiple of 4. B will get cancelled and I'll get a minus c is a multiple of 4. Now a minus c is a multiple of 4. एक नंबर अगर 4 का मल्टीपल है तो उसका मॉड्यूलस भी मल्टीपल ऑफ 4 है. This implies modulus of a minus b is a multiple of 4. So we can conclude a comma c belongs to R, and therefore we can say that the relation R is transitive. So the relation R is transitive. Now we are going to do the B part of question number 9. Question number 9, B part. The set A remains the same. Set A is x belongs to z. X belongs to z means x is an integer. X lies between 0 to 12, means the values that x can take is 0, 1, 2 up to so on 12. The relation R is defined on A as a comma b such that A is equal to b. So we have to show that this relation is an equivalence relation. So we are going to start with the reflexive part. So whenever we start with the reflexive part, we write consider a comma a. Now what does our relation says? Our relation says if a comma b belongs to R, A should be equal to b. Now we know that A is equal to A. So we will write, we know that a number is equal to the number itself. So A is equal to A. This implies A comma A belongs to R for all A that belongs to A. And therefore we can say that our relation R is reflexive. Now next we are going to move to the symmetric part. For symmetric we will write let A comma B belongs to R. Now A comma B belongs to R. This implies A is equal to B. अगर A equal to B है तो B भी equal to A है. This implies B is equal to A, and therefore we can conclude that B comma A belongs to R, and therefore our relation R is symmetric. So we have assumed let A comma B belongs to R. That implies A is equal to B. अगर A B के equal है तो B भी A के equal है. This implies B is equal to A, which implies B comma A belongs to R, and therefore the relation R is symmetric. Now next we'll move to the transitive part. For transitive we will write let A comma B, B comma C belong to R. So definition says A comma B belongs to R means A should be equal to B. B comma C belongs to R, that means B should be equal to C. अब A B के equal है और B C के equal है. So can we conclude that A is equal to C? A equal to C. So therefore we can say A comma C belongs to R, and therefore the relation R is transitive. So we can conclude that given relation is an equivalence relation because it is reflexive, symmetric, and transitive. Therefore, the given relation is an equivalence relation. Now we are going to move to question number 11. Question number 11 says, show that the relation R in the set A of points in a plane given by R is equal to P comma Q such that distance of P from the origin, distance of P from the origin is equal to, is same as distance of Q from origin. Distance of P from origin is same as distance of Q from origin. Now visualize this situation. This is origin. This is the point P. This is the point Q. If P comma Q belongs to R, that simply means OP and OQ should be equal to, should both be equal. So we can rewrite our given relation as this. So we can write, this can be rewritten as P comma Q such that OP is equal to OQ. OP denotes the distance of the point P from the origin. OQ denotes the distance of the point Q from the origin. So we'll start with reflexive. We are going to start with reflexive. So for reflexive, we always write consider P comma P. Now we know that OP is always equal to OP because they are same. Same distances are always equal. This implies P comma P belongs to R for all P that belongs to A. And therefore, our given relation is reflexive. Now we are going to move to the symmetric part. For symmetric, we will write let P comma Q belongs to R. Now we will look at the definition of R. If P comma Q belongs to R, that means OP should be equal to OQ. So we can say this implies OP is equal to OQ. Now if OP is equal to OQ, so we can conclude OQ is also equal to OP, and this implies that Q comma P belongs to R, and therefore we can conclude that our relation R is symmetric. Now we are going to move to the transitive part. So for transitive, we are going to write let P comma Q Q comma R belong to R. Let P comma Q comma R. Actually, we should take some different point because R is already given to us. Let P comma Q comma S belongs to R. Now P comma Q belongs to R. This implies OP is equal to OQ. Q comma S belongs to R. This implies OQ is equal to OS. This all we can conclude by the definition of R. So OP is equal to OQ. OQ is equal to OS. So we can say OP is equal to OS. And therefore we can conclude that P comma S also belongs to R. So P comma Q comma S. A comma B comma C. A comma C belongs to R. So P comma S belongs to R, and hence we can conclude that the relation is transitive. Now the second part of this question is, show that the set of all the points related to P is the circle passing through P with origin as center. Show that the set of all the points related to P, set of all the points related to P. It means P comma Q belongs to R. Q is the set of all the points which are related to P. If I write A comma B belongs to R, B is the set of all the points related to A. A is the set of all the points related to B. Show that the set of all the points related to P. So if P comma Q belongs to R, then all the points which are related to P are Q. So the question is, show that the set of all the points related to P is the circle passing through P with origin as the center. So we need to prove that all the points Q form a circle. That is, we need to prove all the points Q, all the possible points Q form a circle passing through P and with O as the center. Passing through P and O as the center. Now just visualize the situation. For this we have to visualize the situation. This is our origin O. This is the point P. Now let us see at all the points which are related to P. Suppose there is a point Q which is related to P. That means OP will be equal to OQ. Suppose there is a point S which is related to P. That means OS will be equal to OP. Suppose there is a point T which is related to P. So we can say OT is equal to OP. So now you can see that this all form a circle with center at O passing through the point P, and this OP, OQ, OS, OT, these all are the radius. So this is how we have visualized our question. Now, how can we prove this? How can we write the proof? Is we will write, let Q be set of all the points. Let Q be set of all the points related to P. Let Q be set of all the points related to P. What does this implies? This implies OP is equal to OQ for all Q. It means this Q is S, T. तो जितने भी points Q हैं, S है, T है, R है, V है, U है, वो सब OP के equal है. So these points Q form a circle. These points Q form a circle with radius equal to OP. And hence we can say that these points form a circle passing through the point P and O as the center. And hence proved. So this conclude our statement. Therefore, all the point Q form a circle which is passing through the point P with O as the center, and hence it is proved. Now we are going to move to question number 12. Question number 12 says, show that the relation R defined on the set A of all the triangles So R is a relation defined on the set A of all the triangles, and R is defined as T1, T2 such that T1 is similar to T2. Now we have studied in class 10th the sign of similarity. The sign of similarity is this. T1 is similar to T2. Now let us recall what is the similarity means. The similarity basically means that the sides should be proportional. Suppose these are the two triangles. This triangle has the side 2, 3, and 5. And this triangle has the side 4, 6, and 10. So we can clearly say that 2 by 4, 3 by 6, and 5 by 10. So we can say that this triangle is the double of the previous triangle, and hence these two triangles are similar. The two triangles are similar if the ratio of their sides is proportional. And we should know the facts that we have studied in class 10th, that if two triangles are similar to the same triangle, that is, if T1 is similar to T2, T2 is similar to T3, then T1 is also similar to T3. It's just like equality. So we should know these facts about the similarity of triangles before proceeding to this question. So we'll start with the reflexive part. So for reflexive, we are going to write consider T1, T1. Now suppose the triangle T1 has the side 2, 3, 4. Triangle T1 also has the side 2, 3, 4. So 2 upon 2, 3 upon 3, 4 upon 4. They are all equal to 1. So the sides are proportional. So we are not going to explain this. We are just going to write, since T1 is similar to T1, this implies T1, T1 belongs to R for all T1 that belong to A. The reason is very simple. Two triangles are similar if their sides are proportional. So if we have the same triangle, then the ratio of their sides will be equal to 1. The sides are proportional, hence it is similar. Now for symmetric. But this was just for the reference. We are not going to write this entire thing in the proof. For the symmetric part, we will write, let T1, T2 belongs to R. Now this implies T1 is similar to T2. Now consider the example. Suppose this is the triangle T1. This is the triangle T2. This is 2, 3, 4. This is 4, 6, and 8. So 2 by 4, 3 by 6, 4 by 8. They are proportional. Now if we take T2 and T1, so 4 by 2, 8 by 4, and 6 by 3. They are also equal, so they are also similar. So we can say this implies T2 is similar to T1. Therefore, T2, T1 belongs to R, and therefore the relation R is symmetric. I again repeat, this example is just for the reference. We are not going to give example when we prove that this is symmetric. So if the sides are proportional, if T1 is similar to T2, that means the sides of T2 are also proportional to sides of T1, and therefore T2 is also similar to T1, and therefore T2, T1 belongs to R. So we have proved that the relation R is reflexive. We have proved that the relation R is symmetric. Now we are going to move to the transitive. For transitive, we will write, let T1, T2 and T2, T3 belongs to R. This implies T1 is similar to T2, T2 is similar to T3. Now by that same logic, if T1 is similar to T2, T2 is similar to T3, that means the sides of T1 and T3 will also be proportional. So we can conclude T1 is similar to T3. This implies T1, T3 belongs to R, and therefore our given relation is transitive. And hence we can say that the relation R is an equivalence relation. Now the second part of this question says, consider three right angle triangle T1 with sides 3, 4, 5. T2 with sides 5, 12, 13. And T3 with sides 6, 8, and 10. Question is, which triangles among T1, T2, T3 are related? As we know that for two triangles to be related to each other, both the triangles should be similar. And similarity of triangle means the sides should be proportional. Now, if we consider T1 and T2, 3 by 5, 4 by 12, they are not equal. So we cannot say T1 is similar to T2. If we consider T2 and T3, 5 by 6 and 12 by 8, they are not same. But if we consider T1 and T3, we need to check whether the sides are proportional or not. 3 by 6, 4 by 8, and 5 by 10. They are all equal and they are equal to half. So we can say T1 is similar to T3, and therefore we can say T1 and T3 are related. T1 and T3 are related. That simply means T1 comma T3 belongs to R. So if T1 comma T3 belongs to R, that means T1 and T3 are related to each other. Now we are going to move to question number 13. Question number 13 says, show that the relation R defined in the set A of all the polygons. Set A is the set of all polygons. Polygons are triangles, quadrilaterals, hexagon, decagon, heptagon. These are all polygons. So R is defined as P1, comma P2 such that P1 and P2 have same number of sides. P1 and P2 have same number of sides. We need to prove that this is an equivalence relation. So we are going to start with the reflexive part. For reflexive, we will write consider P1 comma P1. Now the same polygon. P1 comma P1. If P1 is a triangle, the second P1 is a triangle. Both of them will have the same number of sides. So we will write since P1 and P1 have same number of sides. Since P1 and P1 have same number of sides, this implies P1 comma P1 belongs to R for all P1 that belongs to A, and therefore we can say that the relation is reflexive. For symmetric, we are going to write let P1 comma P2 belong to R. Now this implies P1 and P2 have same number of sides. P1 and P2 have same number of sides. So if P1 and P2 have same number of sides, then P2 and P1 will also have same number of sides. So we can say this implies P2 and P1 have same number of sides. Now P2 and P1 have same number of sides. This implies P2 comma P1 belongs to R, and therefore we can say that the relation R is symmetric. P1 and P2, let P1 comma P2 belongs to R. This implies P1 and P2 have the same number of sides. So if P1 and P2 have same number of sides, then P2 and P1 also have same number of sides, and this implies P2 comma P1 belongs to R. Now we will look at the transitive part. Now for transitivity, we will write let P1 comma P2 and P2 comma P3 belong to R. Now P1 and P2 belongs to R. This implies P1 and P2 have same number of sides. P1 and P2 have same number of sides. P2 comma P3 belongs to R. This implies P2 and P3 have same number of sides. P1 and P2 have same number of sides. P2 and P3 have same number of sides. This implies P1 and P3. P1 and P3 have same number of sides. Therefore, we can conclude that P1, P3 belongs to R, and therefore the relation R is transitive. P1, P2, P2, P3 belongs to R. So P1 and P2 have same number of sides. P2 and P3 have same number of sides. This implies P1 and P3 have same number of sides. Therefore, P1, P3 belongs to R, and therefore the relation is transitive. The next part of this question is, what is the set of all the elements in A related to the right angle triangle T with sides 3, 4, 5? So T is a triangle which has the sides 3, 4, 5. We have to write all the elements which are related to T. That means if I take T, Q belongs to R, I need to write what are the values that Q can take such that Q is related to T. If we look at the definition of R, it says that the two polygons should have the same number of sides. So we will write Q and T should have same number of sides. They are not related regarding the dimensions of the sides, but they're related regarding the number of sides. So Q and T should have same number of sides. Q and T should have same number of sides. T is a triangle, so Q will also be a triangle. This implies Q is a triangle. This implies Q is a triangle. So we can say that set of all triangles are related to T. The reason is very simple, because T is a triangle. T and Q belong to R. That simply means both should have the same number of sides. This implies Q should also have same number of sides as T. So Q should also be a triangle. And therefore, the set of all the triangles are related to T. The set of all the triangles are related to T. Question number 14. L be the set of all the lines in XY plane. L is the set of all lines in XY plane. R is the relation in L, and R is defined as L1, L2 such that L1 is parallel to L2. We need to show that this is an equivalence relation. So, first of all, we will talk about reflexive. So, for reflexive, we are going to write, consider L1, L1. Now, this is the line L1. A line is coinciding with the same line, or we can say that these two lines, it is parallel, they are coinciding. So we can say, since the line is parallel to itself, the reason is very simple, because it is coinciding. This implies L1, L1 belongs to R for all L1 that belongs to L, and therefore the given relation is reflexive. Now we'll move to symmetric part. For symmetric, we will write, let L1, L2 belongs to R. This implies L1 is parallel to L2. Now just visualize this situation. This is L1, this is L2. If L1 is parallel to L2, that simply means L2 is also parallel to L1. So we will write, this implies L2 is parallel to L1, and therefore we can conclude that L2, L1 belongs to R, and hence our given relation is symmetric also. Let L1, L2 belongs to R. So L1 is parallel to L2. Now we will just visualize this situation. If L1 is parallel to L2, then L2 is also parallel to L1. So we can say that L2, L1 belongs to R. Now we'll move to the transitive part. So for transitivity, we are going to write, let L1, L2 and L2 comma L3 belongs to R. L1 comma L2 belongs to R. This implies L1 is parallel to L2. L2 comma L3 belongs to R. This implies L2 is parallel to L3. Now visualize the situation. L1 is parallel to L2. L2 is parallel to L3. So if L1 is parallel to L2, L2 is parallel to L3. So simply we can say that this implies L1 is also parallel to L3, which implies L1 comma L3 belongs to R, and therefore our relation R is transitive. So our relation R is transitive. Since the relation R is reflexive, symmetric, and transitive, so we can conclude that the relation is an equivalence relation. So the given relation is an equivalence relation. The second part of this question says, find the set of all the lines related to, find set of all the lines related to y is equal to 2x plus 4. So if I take this line as L1, so L1 comma L2 belongs to R. L2 is the set of all the lines which are related to L1. So we need to find that what are the possible values that L2 can take. We need to talk about L2. Now, L1 comma L2 belongs to R. That simply means L1 is parallel to L2. Now, how can we write the mathematical term for two lines to be parallel? We have studied in class 11th that two lines are parallel. Two lines are parallel if they have same slope. Two lines are parallel if they have same slopes. How do you find the slope of a line? Any line which is of the form y is equal to mx plus c, then this m is called the slope of the line. Now, what is our given line? Our given line is y is equal to 2x plus 4. So what is the slope of this line? 2. And since L2 is parallel to L1, so therefore L2 should also have the slope 2. So that is your answer. That means since, first of all, we'll write let L1 comma L2 belongs to R. This implies L1 is parallel to L2. Now, two lines are parallel. If we talk about the mathematical term, two lines are parallel only if their slopes are equal. How do we find out the slope? We have to write the equation in the form of y is equal to mx plus c. So if we write y is equal to mx plus c, so the coefficient of x is m. So y is equal to 2x plus 4. The coefficient of x is 2. So the slope is 2. So we can say that L2 should also have the slope 2. L2 should also have slope 2. Why? The reason is very simple, because L1 is parallel to L2. So the question was, find the set of all the lines related to y is equal to 2x plus 4. So we will write set of all lines having slope equal to 2. Set of all the lines having slope equal to 2 are related to y is equal to 2x plus 4. The set of all the lines having the slope 2 are related to y is equal to 2x plus 4. So this is our answer. This is our concluding statement, that the set of all the lines having the slope 2 are related to y is equal to 2x plus 4. Now question number 15. Question 15 says, relation is defined on the set 1, 2, 3, 4. So this is, we can say that this is basically the set A on which our relation is defined. And the relation R is given by 1, 2, 2, 2, 1, 1, 4, 4, 1, 3, 3, 3, and 3, 2. We have been given some options. The options talk about the reflexive, symmetric, and transitivity of this relation. So first we'll check the reflexive part. So the reflexive says that all the elements which are there in A, their doublets should also be present in the relation. All the elements which are present in A, their doublets should also be present in R. 1, 2, 3, 4. We need to check 1, 1, 2, 2, 3, 3, 4, 4. They are all present in R. So we can say that this relation is reflexive. So since A comma A belongs to R for all A, which are the elements of A, therefore this relation is reflexive. Now we are going to talk about symmetric. Now, so for symmetric, we need to check all the elements. I had told you before that for symmetric and transitivity, we can ignore these doublets. We can ignore the doublets and we just need to concentrate on the other elements. So we'll start with 1, 2. 1, 2 is present in the question. 2, 1 is not present in R. So this relation is not symmetric. So example is 1, 2 belongs to R, but 2, 1 does not belong to R. Therefore, this relation is not symmetric. Now we'll check the transitivity. For transitivity, we need to check all the elements of R, but we should ignore the doublets. The reason for ignoring the doublets is that by default, the doublets will give you the symmetric and the transitivity. We need to search for example where we can say that this relation is not transitive. If we are unable to do that, then we can say that the relation is transitive. So this is 1, 2. Now we'll search for 2, something, ignoring the doublet. 2, something is not present in the question. So we'll move to the next element. This is 1, 3. We will search for 3, something. 3, something is this. So 1, 3 and 3, 2. They belong to R. So their A, C is 1, 2, which is also in R. So Abhi, this is transitive. Now we'll move to next part. The next part is 3, 2. Now we have 3, 2. We need to search for 2, something. 2, something is not there. 1, 2, 1, 3. 2, something is not there. It means we have got only one condition to check, and on that condition it was transitive. So therefore this relation is transitive. So this relation is reflexive, transitive, but this relation is not symmetric. This relation is reflexive, this relation is transitive, but this relation is not symmetric. So option B is the correct option, which says R is reflexive and transitive, but it is not symmetric. Now the last question of this exercise is, R is the relation on the set N. Relation R is defined on the set N. Relation R is defined on the set N, and R is defined as A, B such that A minus B is greater than 6. Sorry. R is equal to A, B such that A is equal to B minus 2 and B is greater than 6. We have been given certain options and we need to check which of the option is correct. First of all, we'll check 2, 4. So this is A, this is B. A is equal to B minus 2. So 2 is equal to 4 minus 2. This is satisfying the first condition. Now we'll move to the next condition. B is greater than 6. 4 is greater than 6. It is not satisfying the second condition. So we can say that 2, 4 does not belong to R. So option 1 is wrong. Now we'll move to second option. 3, 8. A is equal to B minus 2. 3 is equal to 8 minus 2. This is A, this is B. 3 is equal to 8 minus 2. 3 is equal to 6. Not possible. So the first condition itself is not satisfied. So B option is also wrong. Now we'll move to the C option, which is 6, 8 belongs to R. Our two conditions were A is equal to B minus 2 and B should be greater than 6. So this is A, this is B. 6 is equal to 8 minus 2. A is equal to B minus 2. 6 is equal to 6. So it is satisfying the first condition. B should be greater than 6. Here the value of B is 8. 8 is greater than 6. It is satisfying the second condition also. So therefore we can say 6, 8 belongs to R, and therefore option C is the correct option. Now if we check for option D, 8, 7 belongs to R. This is A, this is B. First of all, A should be equal to B minus 2. 8 is equal to 7 minus 2, which is 5, which is not true. So option C is the correct option of this question.